please welcome Oliver Winzenried.
Okay, thank you very much. Welcome everybody. So it might be a little bit more technical than the last presentation, but it's a similar topic. So I will talk about chances of digitization and how to realize them with licensing and with security. And some solutions for security and licensing, really the same solution can be used for both. I will see, is it working? It's working. Okay, not here, yeah. So first of all, it's about digitization and features in devices, in machines, in equipment, and we see changes from devices and systems today, which are in many cases, or in the past, in many cases, standalone devices with a fixed feature set that you sell exactly one time, so you create one-time revenue. Maybe you create an additional revenue for repair, but that's it. And in many cases, it has been an individual hardware. That is changing today and for tomorrow. More or less everything is somehow connected. You will have upgradable features like on your smartphone, not a fixed feature set when you buy a device. And as a device manufacturer, you can create recurring revenues. That means you not only make revenue when you sell it the first time, but you can also, after sales, create new revenue with pay-per-use models, with feature on demand that are activated. You can realize new business models, have a shorter time to market if you sell your device with basic functionality earlier. And you can speed up the development process and engineering process if you are using standard platforms for software and hardware. Security, of course, is really important, and I have seen the same picture in the presentation from Mr. Mader just before me. It's a picture out of the IIC Security Framework paper, and it says at the end that security enables the other characteristics of IIoT, trustworthiness. So for the trustworthiness of devices, you need security to realize that, security against fault of the systems, security against disruptions from the environment, security against cyber attacks or attacks from intentional attacks from the outside. And of course, you need security against simple mistakes as well from the inside. So security is really necessary to drive all the new things with embedded systems. So now OPC UA has been in the title already, and many of you might know a lot about OPC UA, so I will talk only about a few basic things from OPC UA from the security standpoint. So OPC UA helps you to get a secure channel authentication, to get that vendor independent. It's an open standard. So that's excellent. Certificates are used, public key schemes are used for authentication, symmetric encryption is used for channel encryption. So all these options are standard in OPC UA. They only need to be switched on. So if you use OPC UA in the embedded systems, your devices that are connected somehow, you get a high security level for all the data that is in transit. It's always a little bit slow in changing. So OPC UA on the other side is very widely supported today. It's supported by the platform Industrie 4.0. There has been a study on our security evaluation of OPC UA from the German Bundesamt für Sicherheit in der Informationstechnik, so that's the Office for Security in IT from the government in Germany. It's supported by the IIC. It's really supported globally. Also, the Chinese Alliance for Industrial Internet is supporting OPC UA and recommending that. So that's a good base for using such a system. And what you want to reach with your embedded systems, your control units, is that you have this security on all your endpoints. And endpoints are really everywhere. Endpoints are on the edge, sensors, actuators, motor drives, robots, all are endpoints. And everybody immediately understands that these are endpoints. But you have the endpoints also in the computational network. You have it in the cloud. So endpoints are more or less everywhere where the data is transmitted to and received from. So And of course, it's necessary to have these endpoints secure. So if you are looking on OPC UA, we see the green lock on the communication channel. And that is what OPC UA realizes for you. It also realizes the authentication of the endpoints, but you need to do more on your endpoints. So the operating system running on your endpoint might be vulnerable if it's not protected. That's nothing OPC UA can do, but that's necessary. Software libraries, applications running on the endpoints needs to be secured. If you don't have that, the endpoints can be manipulated. There can be maybe certificates or cryptographic material can be stolen, so then the authentication is no more secure. Configuration data can be manipulated, application itself. So very important to secure this endpoints as well. And if I'm looking today on implementations of OPC UA, if I'm looking in a machine or in a production setup, in many cases, the private keys and certificates are simply stored on the file system of a device. The trust lists, revocation lists also stored on the file system, and the applications running on this PLCs or running on the embedded system are not protected against tampering. And that makes it possible for hackers and for any cyber attacks from the outside to attack these endpoints. So they can, if they are able to get the private keys, the certificates of the communication, they can penetrate the whole infrastructure, which might cause loss of functionality, reliability, and the theft of IP. So that's a bad thing. So what can be done? And this is only a sample where we have integrated our CodeMeter technology into an OPC UA stack. That can be done by other means as well. So the important thing is here that the security relevant information is not simply stored in a file system on the system, but it's stored in a kind of secure element. That can be a TPM, that can be a CodeMeter hardware device that stores cryptographic keys and is doing the crypto operations. And it needs to be a small footprint so that it can easily be integrated into the communication OPC UA stacks. So what's important here is the protection of the private keys in a secure hardware element, the execution of the cryptographic operations, symmetric and asymmetric, storage of trust lists, of revocation lists, so that it is tamper-proof and not possible to attack it from the outside. So that will help to increase the level of security for the endpoints and for the implementation of the security profile in OPC UA. Having such a system that can store cryptographic keys and doing that with CodeMeter also enables the features of licensing. That means if you have a device, a sensor or actuator, it's not only that it communicates, it also is fulfilling having some software realized features in that device. And you can produce one device and sell it to the customer with different options. And these different functions have a different price and they are sold separately. Here we come to the business models, to the chances that you have in selling it in a tailored way. And the same system that is storing the certificates and cryptographic keys for the secure communication with OPC UA, the same system can store this license information and this configuration, how the software can be used. And additional to that, if you have to update this license information, for example, a user wants to buy some additional features, some additional functions, the updating process can use OPC UA communication itself. So there's no additional communication channel required. Yeah, this solution, what we did for OPC UA, is available for the OPC UA SDKs from Unified Automation, but it's also adaptable to any OPC UA stack or any OPC UA SDK. We have evaluated that in several research projects with the Smart Factory KL. On the opposite of that booth, in that demo production, we have this OPC UA implementation in two solutions. One is this driverless transport system, and the other one is a dashboard, the SAP production Pico. It's what's the name? Pico. It's I don't know, production something. It's a monitoring system, and it's a OPC UA client, and the certificate and private key for the secure communication is stored in a device from us. So you can have a look on that on the booth behind this forum. Yeah, let's go to licensing. I said in the beginning that it's a little bit like on your smartphone. You purchase a device with a basic functionality, and you can, after sales, you can activate additional features, and that really fits for all kinds of industries. So even here in this sample, what you see here is a ventilation unit. That's a medical device for a life-critical medical device that is used in emergency helicopters or emergency cars or in the intensive care of the hospital. But these manufacturers of these embedded systems are also under high pressure through the global competition. So they need to offer their device with basic functionality for a reasonable, low, competitive price. But their USPs, they can sell additionally. For example, in these ventilation units, special applications for newly born children are special features that can be activated on top. And so the device manufacturer can create new business models. If we are looking in the industrial automation area, you have a lot of IP in the PLCs of your machine. And with integration of, so this intellectual property in the programmable logic controls can be protected, and the security can be offered as a service. So that means that you as a developer can implement it quite easily because it's implemented in the development tools you are using to create your application. For example, in development tools for PLCs from Rockwell Automation, Studio 5000, or in a development tool called Dave for microcontrollers, or in a development tool called AX Protector for software running on Windows, Linux operating systems. And that makes this security of a service makes it quite easy for you to implement that and to use that. Mr. Mader, the presenter before me, spoke about the value of data. And this is a quote from Dr. Festke, the former president of the VDMA, the German Engineering Federation. And he also focused on the value of the data. So the value of the data is getting higher and higher, also in the production process. Think about embroidery data in textile industry, think about 3D printing data for additive manufacturing. So data protection for this data is quite elemental for the new business models. And if these flexible business models through licensing of software realized features, licensing of data are done, the user benefits from tailored products. So he don't need to use to purchase a product with a lot of features that he don't need. It can be exactly configured in the way he wants it, and that can be done in an easy process. He only pays for what he needs. Nevertheless, what he purchases is future-proof, because at a later time, if he needs an additional function, an additional feature, he might be able to upgrade this. And of course, security and reliability is user benefit if that can be upgraded as well. And for the device manufacturer, he can get a faster return of investment when he makes the product modular and sell it with basic functionality first, faster to the market. With new business models, he can get these recurring revenues, and he can also have, with this upgrade possibility, a renewable security. Security, and I cannot go into details here. With security, you have never finished the development. Encryption algorithms and key lengths that are offer today a high level of security might be no more secure 5 years later with new technologies coming. So renewable security also something which is very important. Yeah, and so now for the device manufacturer, using licensing and security systems, they can really empower their creativity to think about new service features offered to the customers, get recurring revenues, get after-sales business for devices, of course protection against counterfeiting and piracy, and making sure the integrity of the whole system. Connected systems in the IIoT or embedded systems are more vulnerable due to the connectivity and the communication. The complete product feature is more defined by the software than by the hardware if we are having standard hardware platforms. So all these trends in the Internet of Things are this, then new business models are coming, multiple manufacturers can have applications on the same system, new use cases, new services can be offered, and even simple components require protection today. And the question for you, of course, if you are a manufacturer of embedded systems of intelligent devices, do you implement and develop all the security and licensing mechanisms yourself, or is it easier and faster to rely on an industry-grade professional solution that's on the market? I would also recommend to focus on the own core competences and to use a licensing and protection system that is commercially available. Of course, it's important to use standards wherever standards are available, like OPC UA for communication, like MQTT, DDS, and in the encryption case, of course, no security by obscurity. That is in most cases weak, even if people think it's complicated. So for security, it's always possible that it's open, published mechanisms that can be audited, that can be evaluated by people or authorities that understand it. Blurry box cryptography is one sample for software protection with completely published mechanisms developed by Karlsruhe Institute of Technology and Research Center Computer Science together with WIBU-SYSTEMS, and we are just now at this show starting a competition where we have issued an award of €50,000 for somebody who is able to bypass this protection, to crack this protection within 3 weeks. Now we are coming to the end. Yeah, simplify implementation also is about the business process. So if you are using licensing in your embedded device, in your products, then you have to do it, you should do it in the same way like Apple or others are doing it on the smartphone. So activation of feature should be easy. It must be a full automatic process, integrated in an e-commerce application, integrated in your SAP system, so that it's scalable to a large number of devices, and that the transfer of configurations and licenses to an IoT device is full automatically through the cloud. And for that full automatic deployment in the cloud, we have a sample at our booth. I thought showing it here, but maybe the time is too short, so I think if you like to see it, please come to our booth in this hall on the border to Hall 7, 8DU5, you can see it. Samples for new business models. Another one in the medical equipment is computer radiography. These medical large systems are very expensive, and for the hospitals in Western Europe, in the US, it's not a problem. In some countries in the world, they cannot afford the high investment of such a machine. So what Agfa is doing here with their easy payment scheme for computer radiography is they install these machines for very low cost in the hospitals, and then later they make a pure pay-per-use system. So every picture that is made with this diagnostic system is counted and invoiced from Agfa to the hospital. And the advantages for the people living there, they have a chance to get this high-quality diagnostic service, and otherwise the hospital would not be able to install such a machine. That's one sample, and there's another one. Other sample with IP protection, with licensing of different features in the automation industry, so in PLCs. And what's used in PLCs is IP protection for the PLC itself for the PLC manufacturer, like a Bernecker or Reiner or Codesys or Rockwell, for example, but also the content protection of the software in the PLC developed by the machine manufacturer, integrity protection against tampering, and then with that licensing, also the option to monetize the software realized features in a machine. Yeah, that's it so far. In half an hour, it's a lot of content. If you have any questions, I would be happy to welcome you at our booth 8005. I will wait a little bit here around the forum as well. Yeah, thank you very much for your attention.